How does SEM find microcracks and voids? Imagine trying to spot tiny cracks or empty spaces inside a solid object without breaking it apart. That's where scanning electron microscopy, or SEM, comes into play. SEM uses a focused beam of electrons to scan the surface of a material. When these electrons hit the surface, they produce signals that tell us a lot about what's happening there. These signals include secondary electrons, backscattered electrons, and other emissions that reveal surface details. Because SEM produces images with very high resolution, it can show features as small as a few nanometers. Microcracks and voids appear as sharp edges or dark spots in these images. They stand out because their surface structure is different from the surrounding material. For example, a crack might look like a thin line cutting through the surface, while a void appears as a dark, empty space. These differences happen because electrons scatter differently when they encounter a crack or void compared to solid material. In failure analysis, identifying these tiny flaws is essential. Sometimes a crack starts small and grows over time, leading to a bigger failure. SEM helps find these early signs by providing clear images of the surface. It's like zooming in with a super-powered magnifying glass that shows details invisible to the naked or even optical microscopes. More advanced techniques combine SEM images with computer algorithms. Artificial intelligence models analyze the images to automatically locate cracks and voids. These models recognize patterns in the surface features, even when the defects are very small or hidden within complex backgrounds. They can draw bounding boxes around the cracks, making it easier for engineers to see where the problems are. This combination of imaging and computer analysis makes defect detection faster and more accurate. In practical use, SEM reveals the origins of many failures. For example, in electronics, tiny cracks in silicon chips can cause devices to malfunction. In materials science, understanding how cracks form and grow helps improve manufacturing processes. By precisely imaging these tiny flaws, SEM guides engineers in diagnosing failures and designing stronger, more reliable products. So, in simple terms, SEM finds microcracks and voids by creating detailed images that highlight surface irregularities. It's supported by smart computer analysis that helps detect even the tiniest defects. This process is vital for understanding why products fail and how to prevent future problems.